Number two about the element of high quality program. So basically, what you learn is this one. You learn the process of declaring and using variable name and constant here. Perform some of arithmetic operation. The advantage of modularization, right? And modularizing the program. You use the hierarchy chart, and you have the sum of feature of good program design here. So basically, when in the process of declaring and using variable and constant here, so basically it depends on the programming language. Some of programming language require you that before you use the variable, you have to declare that first. Think about if you work with the C or C++ here. Before, think about the process here. Right? Think about the process I want to give the assignment X here equal to number 2. That's the process I want to use the variable name X here. Right? So in some of the programming language here, they require you have to declare the variable before you use it. Right? So think about you have to declare here. Declare. Right? If the X here is a number format and I have X here, I have to declare it before you use it. But in the Python, you don't have to use it. Right? So this one is about the computer logic. So it should be better that they instruct you how to define the variable before you use it here, right? So it depends on data type. You have many types of data type, but in this class here, it breaks it down into two categories here. The first one is number format. The first one is number format. The second one is string format. Right? So number format, that means everything is a number. You know that's the number here, right? Think about you have number 5, -2, or 7.5, or so on. Everything is a number. It is a number format. Right? String here, everything in literally the text here. I think about your name, right? Your name is David here. That is string format, right? That's string format. So remember that everything, if you want to use a string here, you have to put it inside the code market. Right? It's a literal text here. So think about I can have my that's the process here. That process if I want to initialize my name with David here, so I can use name here. Sorry. I use the name here. Right? So remember, if I want to assign my name with David, I have to use the format here, David here. Right? That I know that it's in the string format. Right? And if what happened here? What happened if I put the name equal to David here? What do you think? Actually, that's the process of assignment, right? You assign the variable, you store in the variable name David here, because computer understand David here is the variable name, not string format here, not literally text here, right? Okay. So basically, for this class, you learn about the two categories of the data type here. The first one is the number format. The second one is string format here. Number format, it consists of numbers that can be used in any mathematical operation here. A string is anything you not use in math. That to make it simple. But actually, you can concatenate them together. Later on, we learn about the process of concatenation here, right? Okay, so data type in this graph, what value can be held by the item? So think about I declare the variable here, right? Declare here. Declare here. Number is the number format, right? So I have number 1 here. So that what is the process? The process here, I define the name. Variable name is number 1, and I define it in the number format here. Right? So when I got the number 1 here, I can do anything with the mathematical operation. Right? I can add it to the other number, or I can multiply it to the other number, and so on. But remember the number here is the number format. That means I cannot, right? Think about I put here number 1 here. I put it with the David here. I got the syntax error because I cannot assign the number format to the string format here. Right? So basically, in this class here, you should understand that you have two categories. The first one is number format, everything about the number. The second one is string format. I think about the name, and so on here. Right? Okay. Okay, so again, you have the variable, right? Variable. I mentioned the variable is something changeable, right? The other thing you can use, you can have is a constant here. constant, that means it always stays the same. It always stays the same here. Think about one example of constant here. Think about the state tech here, right? State tech rate here. So it always 7%, right? It always 7%. So we have 0.0.7 here. So whatever it is, it always stay at the 0.7 here. So it depends on your spending here. So if you spending for 100 here, here is a 7, right? If you spend for 1,000 here, you have the 70 here. But whatever it is, you only have the same rate here, it's the 0.07 or 7% here. Make sense? Okay. The constant, remember here, the constant here. The constant is someone always stays the same. And again, constant the same. The constant also have the two type constant here. The first one is a number constant. Everything is a number. Think about this one here. Right? It is a constant here. Right? You have the state tag here, 0.07. The second one also, you can have the string constant here. That means that is something in the text format and always stay the same. It's always stay the same here, right? That's the process here. And remember here, the string are enclosed into quotation mark. So whenever you see everything into quotation or double quotation here, they are in string format, right? Okay. Okay, so you know the variable, right? The variable are named memory location. Right? That's why you see whenever you do anything with the calculation here, I think about I have the process here, right? I have act, I assign to number 20. That is process. Actually, I have memory location here, and the name of memory location here is act, and I store value 20 in that location. Right? And remember here, the variable is something changeable. It not always stay the same. Right? So let's time I can store number 30 or 40 or 50 here. It doesn't matter because it is changeable. It's a variable here, right? And the content here can vary or differ over time. So basically for this class, from now on, I expect you that whenever you use any variable here, you have to declare it first. So what you do with the declare, that means you declare its name and the format here. It can be number format or it can be string format in this class. Right? Think about this one. If you want to do the declaration here, you have to define the data type. It is number format or string format. Right? Identifier, that means the name of variable, right? And optional here, you can have initial value. Think about if before I use a variable here, I use a declare here. Right? So I have the number here is the number format, and I put X here. So what is the process? Actually, I define one slot here in the memory with the name X, and I also define this X here. It always store the number format away, not string format. Right? Also, I can do the optionally here. I can have initial value. What is it? I can define here. Declare number here, and I put it the number 10 here. That means I assign the number 10 to the variable X here at the beginning. I can do it. Right? It's optional. It's up to you. It's up to you, right? So think about this one here. Example here, declaration here. This is a number format, right? My monthly income here, it is a number format. My name here, it is a string format here. Make sense? Or I can initialize by I put it here, David here. It's okay. And later on I can change it later. It doesn't matter. Make sense? Okay. Okay, so here's the process. Right? The process from now on, I expect that when I work with any serial code program or the flowchart program here, the first step here, right? You have the start and the stop for sure. But the next time here, you have the declaration here, right? Declaration, you know that you have to list it out all variable you use in your program, and also we have to define the format for them. Right? Think about for this one here, I have two variables, my number and my answer here. They are in the number format. Right? So now I do with the get input, I double it, and then pack it out the output here. That's all. And when you do the flowchart here, and I work with the serial code here. Yeah, so again, everything about the numeric variable, 2-digit, right? And it can perform the mathematical operation on it. Anything about string variable, it can hold text, right? Letter of alphabet, special character, and so. Make sure I prevent assign value of an incorrect data type. So if it's a number format, you can assign with the text format, and the other way. Identifier, that means it's a variable name. It's variable name, right? You have the sum of the specific rule for the variable name here. Programmer choose a reasonable and descriptive name for variable. So what is it? You think about if you have very complicated program, you have a lot of things going on here. It should be better you give them specific name, reasonable and descriptive name here. Right? Don't use anything about X or Y or num or so on. If you see, if you have many things going on here, you have to make a decision. What is X and what is the purpose of X and what is Y and what is the purpose of Y, right? So make it reasonable name. Think about X here instead of you use it monthly income here. Right? So when you look in the program, you know that this is store the value from the monthly income of the employee here. Think about that, right? So don't use anything unreasonable. You use a program here, you choose a reasonable and descriptive name for variable here. And programming language have some specific rules for creating the identifier here, right? Most language allow the letter and digit. Some language allow the hyphen, and reserved keyword are not allowed here. Think about if you work with the Python, right? You can use a print as the name here because it's a keyword, right? Okay. Input also you cannot use the variable name because it's a keyword here, and it depends on specific programming language. You have to know about that one. Okay, and remember the variable name, they are case sensitive, right? That's why you have to, some of you make the simple mistake here because you have the inconsistent variable name. So if you use the you use the variable name, you have to pay attention. They are case sensitive here, and variable name must be one word only, right? Must be one word only. Must start with the letter, and you should have the some appropriate meaning here. That's what I mentioned already, right? So remember here, it's very important. It is a case sensitive. It is a case sensitive, right? Okay. Yeah, that process here, right? And also you have the sum of convention. It's the sum of the convention when you put the name for variable here. The first one, the camel casing here, variable name have the hum in the middle. Think about you have hourly wage here. You have the hum in the middle here. This one, right? Sorry, this one here, right? And also you have the Pascal casing here. Its variable name has the first letter in each word in the uppercase. Think about this one and this one here. So basically you have many conventions for variable name, but they strongly recommend here, if you follow one specific convention, you have to be consistent with this one. Right? So don't mix between the Camel and Pascal or Hungarian here. But anyway, you can choose whatever you want here. But it should be better if you to be consistent with the convention you use. Okay? Okay, so now you know that you have to, before you work with the program, right? You have to declare variable. In the process of declaration, you have to tell the format and you have to tell the name of the variable, right? And the next process here is assignment. Assignment, actually you did it for multiple times already, right? So assignment here, that's the process. I give the number 10 to the variable name, my number here. Right? That's the process of the assignment. Or I can give it here. My answer is my number times number 2 here. So remember one thing here. If you put the variable on the right here, make sure you have to define it first. Make sure you have to define it first, and make sure you have to initialize it first. I think about I have my answer here. I put it my answer here. Right? Equal to my number. time 2. So what is it? In this process, actually the computer only execute from the right first. It always execute from the right first, right? On the right first. So what is it? It try to locate for my number. It try to locate for my number. If I do not initialize the value for my number first, I have the syntax error for sure. Right? So basically, if you want to use a variable on the right here, make sure you have to initialize and you have to give it some value first. Otherwise, you have the syntax error. Okay? So think about if you do with the Python here also, right? You go to my Python here and I copy the process here. Right? So I just do the process. Yeah, I copy this one. And I go to the Python. And I can work with the interactive mode, right? So I paste it here and can see what happened here. Right? If I paste it here, I have the syntax error. Right? I have the syntax error here because again I explained it already, right? The process here, it executes from the left here. Right? So program try to locate where is my number. Nowhere. You have not defined nowhere. Right? You have no value for this one. That's why you have the syntax error here. Right? That's why when you work with the processing here or assignment here, if you put the number on the right here, make sure. If you put the variable on the right here, make sure you have to initialize before you use it. Right? Okay. So now I can correct it by the process here. So I want to use it first, right? If I want to use it first, I have to initialize first, right? Think about I have my number here. I put it with the number 5 here, right? And after that, I can do the processing here. Right? After that, I can do the processing here. And now if I want to print out my answer here, I put it here. I have number 10 here. Okay. So that is a process of assignment operator, right? So when you work with the assignment operator, you have the equal sign here. For sure, right? You have the equal sign here. That is assignment, right? So assignment. So when you work with the assignment operator here, when you work with the assignment operator, you have to use the equal sign. You have binary operator. You have the binary operator, right? That means it requires 2 operands, one on each side here, right? And if you have anything, it only operates from the right to the left. Make sure that. So see, you only execute everything on the right first. And after you figure out the value, you assign that value to the variable on the left. Okay? And it means that you have the right associativity or right to left associativity. Sometimes, right? Sometimes you're able to initialize variable. I think about in the process of the declaration. Right? It's the process of declaration here. You declare the salary here in the number format, and also you can initialize with the 1455 here. It's okay. And later on you can change it. It doesn't matter because it's the variable. You know that, right? Also, this one also you can initialize by your name with a string format here, and you put the name here. You assign the value Janita here. It's okay, right? The garbage, that means the variable unknown value here. That means you just declare it, but you never ever use it in your program. That's a garbage, right? And also, in the processing of getting value from user and stored in variable, you know the process, right? You have to use the prompt here. Output, that means the key. That's the keyword. That is the prompt to tell user what they are supposed to do, right? And you store it into variable name just generate here. Okay. And in this class here, variable must be declared before they are used in the program. But I mentioned it depends on specific program. And later on, when you learn about Python, you don't have to declare it first. But it is good practice here. You know the process you have to declare before you work with the variable here, because when you work with the C or any other programming language, some of them they require you define first, declare first before you use. Now, you know that the constant here, right? Constant, that means something not changeable. It always stays the same, right? It always stays the same here. So think about for this one here, right? Think about this program. I think about I have my program. I have my program here. How's this one? Yeah, think about I have a price here, right? In my program, I got the price here. I assign to 1,000. And now I want to figure out what is my tax amount here, right? some tag amount here, I can use this one. Now I print tag amount. Sorry. Yes, my mistake here, right? Because it's case sensitive, right? That's why I have to change it here. Okay, this one. So this is a very simple program, right? I got the input from user. I store the 1000 into variable name price here. And later on, I figured out what is the tag amount. So what's the tag amount? You got it from the price and time to the tag rate here. So I can guess it. I look at this one here. For sure, I can guess it for this one. 0.06, that means 6%. That is the tag rate for this one. I can do the guess here, right? Because it is very simple program. But don't use it in your program. It's not a good practice for programming language. So whenever you want to use a constant here, give it some name. Even constant always stay the same, give it some name. Because if you have a lot of things going on here, you see in your program, a lot of things going on. Sometimes you have to try to guessing where 006 come from. I don't know where it come from. Right? This one is very simple. You make a guess, you know for sure it's the tag rate ratio here. But if you see you have a lot of things going on, sometimes it's really hard for you. Or if you hand over to the other guy here, you have to keep guessing here where it come from here. So it should be better, even with constant. Give it some name. Give it some name, right? So instead of my program here, right? So instead of using my program here, I can do the same process here, right? I can do the same process. I give it the price here. I got it from user for 1000 here, right? And now instead of timing with the 0.06, I can use a constant name here, right? I can put the tag rate here, right? I can put the tag rate here. I assign 0.06. Okay, and later on I can do the same process here, right? I do the same process. I put it here. I change this one with tag rate. And now I just print it out. Okay, so basically this program and this program, they are the same. They deliver the output the same, right? But from the programmer point of view here, this way it way better because it's really easy for him to follow up what's going on with the program here, right? So he look on this one here. He knows that tag rate here is 6%, and after that you figure out the tag amount from the price time tag rate here. Otherwise, you see a lot of things going on. It's very hard for you to keep guessing where 0.06 come from. Okay. So I think you guys should take a short break for 5 minutes and we come back. So you know that the process, right? From now on, I expect that whenever you do the program, you have one more step of declaration, right? Think about this for this program here, right? You have to do the declaration here. Right? And think about this one, right? So you have to look on this one. You know that for this one, you have to find out how many variables you use, right? So for this one, you have my number 1, my number 2, my answer number 1, and my answer number 2, and my answer number 3 here. All of them is a number format, right? So it should be better. I define with the declaration here, and I put all of them is a number. Sorry, all of them is a number format here, right? I have indentation here, so I give all of them, right? I give all of them here. All of them. Number 1, 2, and so on. Right? I can put it here. And so on. I can put my answer number 1, my answer number 2, and 3. This one it should be better. I put the total here, addition or subtraction here. Make more sense. So I can do the same. I put it here, number 2. Do the same. Put it here, number 3. And so on. Right? From now on, I expect that for any program, after start here, you do the declaration for the variable. Okay, so the process, right? You have the start program, you got the declaration, you got the input. Now, so after you got the input, you do the processing, right? One of the steps is the processing here, you use the operation. Right? So in the operation here, they are the symbols that perform operation on value that you have the assignment operator. You know that the process you use the equal sign here, right? You use arithmetic operation here. You can plus them, you can add them together, you can subtract them together, you can multiply them together, you can divide them together, you can divide with the integer number. This is the process thing about the process here. Alright, if you divide this one, you have the 10, you divide, sorry, not 10, 11 here, right? You divide this one for number 2, you have integer number only. It's number 5 only, right? Okay, this one, for this one, if you have 11 here, you divide by 2, you have 5.5, right? But if you want to take the integer number only, you use this one here, if you have number 5, and this one modulus, that means remainder, right? So if you have 11 here, you modulus to the number 2, you have number 1 here because you have 1 remaining, right? Okay, and this one is the exponent here. So think about, you have 2 here, you have number 4, or 2 3 here, right? You have number 8 here. 2 times 2 times 2, 3 times. You have number 8, right? That's it. Also, we have the some other operation also. You have the some other type operation here. Comparison operation, right? You remember that if you want to compare them together, you have to use a double equal sign, not a single equal sign. Single equal sign, that means operation of assignment. Right? Think about x equal number 5 here. It's not comparison. It is assignment. That means you give the number 5 here to variable name x here. That's the process. You store number 5 into variable name. That's the assignment. But if you want to use a comparison here, I think about, I have y here, right? I have y here and I store the value of 6 into y here. If I want to compare them together, I want to check here if x equal to y or not. So it will return true or false. Right? So you have 5 here. If I want to compare to 6, it turns out to the 4. Right? Some of you make mistake because if you want to compare, you only use one single assignment. It's not correct. If you want to compare them together, you have to use a double equal sign. Right? This one not equal. This one less than, greater than, less than or equal, greater than or equal. And later on, also you learn about the logical operator also. You have and or not also when you learn about the truth table and logic gate, you will learn it later. Okay. Now I come to the process. So about the performing arithmetic operation, they have the table of the priority here. Not all of them the same, right? So the first priority is a parenthesis. You have to execute everything inside the parenthesis first, right? The next one is the exponent. And the next one is a multiplication and division and modular. They are the same. And the last one, you have addition and subtraction here. And actually, the last one is assign. Right? So each of them, they have the priority order here. They have a priority order here. Number 1, right? Number 2, number 3, 4, and 5 here. The first one, parenthesis. The second one, exponent. Right? Multiplication, division, and modular, they're the same. Right? Addition, subtraction, they're the same. And the last thing, assignment. Right? So think about this one here. If you want to figure out the x here, you have to do everything inside the parenthesis first. Right? And so on here. Now, I think one of the key concepts in this chapter number 2 is about the modularization. So what is the modularization? Modularization, that is the process. You break it down the program into multiple smaller modules. I think about, I have the 3 children, right? I have the 3 children. So every week I give them that, take the dirty clothes and do the laundry. They keep arguing to each other. Oh, I do this part, and so on. So it's very helpful for me. I break it down into smaller here, right? So this guy take the dirty clothes. This guy put it into the water, right? And put it out the liquid. And this guy take it out. So that's the process of modularization. Modularization, that means you break it down a program into the multiple modules. into multiple manageable module here. So you have a lot of benefits when work with the modular structure here. The first thing is that it breaks it down into smaller manageable module. It's very easy for you to understand what's going on with each module here, right? The second one here, you can reuse it. It's very important. You define one, but you can later on you can reuse it in your program, or you can import it from another program. Also. It's really helpful when it works the modularization here, right? So to understand the concept of modularization, the first thing you have to understand the concept of module here. Module here. So module, that means you break it down the program into the multiple module, right? There is it is a subunit of program problem here. So sometimes they call it is a subroutine or procedure or function or method. They have many names, but the process the same. You break it down into the smaller structure here, right? Smaller block here. Sorry, block here. And to call the module, it uses its name to invoke the module and causing it to execute here, right? And the process of modularization, that means you break down a larger program into the module, and sometimes they call it the functional decomposition. So we think about, you have a very complicated program here, a lot of things going on, right? A lot of things going on. You can break it down into the one module, in the second module, and the third module here. It's very easy for you to follow what's going on here. And it's easy for you to understand. And again, later on, you see, you have a lot of benefits when you work with the modularization. Okay. So how we do with the modularization in the zero code and the flowchart here. So basically, if you want to do with the modularizing program, remember every program you have main program. Every program you have main program. So whenever you execute program, the main program is the one who will be executed first, right? The main program will be executed first. So every program you have the main program. What you have in the main program, you have basic step of the program. You have start and stop here, right? Also, what you have include in a module, you have module header, you have module body, and you have module return statement. Later on, I explain the concept of the header, of the body, and return statement here. And you know that when you break it down the module, you have to give it name. You have to give it some name, right? So what is the name? How can you name the module here? It's quite similar to the variable. It's quite similar to variable here. And module name are followed by the set of parentheses. That's all. Think about I have main program here. I have the start here, and I have stop. That is main program. You have start and stop. So in the main program, you can call to other module. They think about here. I can put here module number one. I can call it module number two, and I can call it for the module number three here. I can call it later. So when I call to module number one, what is it? The program stop from this one. Execute. It's jump into the module one. You have to define later. Execute everything in the module one, and you return. You remember that each module you have return. So when you return, you come back to the main program and you move to the next step. Now to make it simple here, let me do it one by one here. Let me do this one. Now think about this one. All right. So when a main program want to use a module, you have to call it. All right. You have to call the module name. You have to call the module name here. So think about it. It's my main program here. It's not only main program. It can be the parent here. It can be parent here, right? So what is it? When you call the module here, right? When you call for the module here, what is it? Program stop from the main program. It stop from here. It not execute for next step. It stop from here, and it jump to the sub module you define here. Right? See that module sub and that module sub. So when you call for the module, it jump into the module you define later and execute every statement. Execute every statement inside that module. So when you come to the last statement here, you have return here. Right? You have return here. So when you come to the last statement here, you come to the return, you come to the program that call you, and you move to the next statement here. That's the process. That's the process. Now, later on, I show you one very simple example when we work with the Python here, so we can see what happened. with the main program here. But for now, I expect you to understand the concept here. So whenever you call any module, it can be from a main program or it can be from another module, right? Because later on here, from the main program here, right? You have the main program here, you have start and stop here. So you have the module number 1 here. Right? Module number 1 here. But later on, module number 1 also, you can break it down into the multiple modules here. It depends on the program, right? Sometimes you break it down into multiple level of module, not only from the main program here. But the concept here, I just want you to understand the concept here. So whenever you call any module from any specific program, it will stop it from here. Right? Whenever you call it, stop it from here. It not execute for next statement in the Z program. Actually, it jump it to the module you call it here. It jump into this one. Right? And we see execute every statement inside that module. And when we execute the last statement here, you have to go back to the module, to the program that call you, and you move to the next statement. That's the process. When you call the program, when you call the module. Okay. Here, think about this one. So in the flow chart, right? In the flow chart here, if you want to use the module structure here, you can use a rectangle with the toolbar on the side here, or I can use a rectangle on the top here. It's up to you. It doesn't matter. The two ways it work. This one also work and this one also work. Right? But remember, if you want to use a module in the flow chart, you can follow on this one or this one here. It's up to you. Now think about this one here. Think about this program. If you look on this program here, you can see how they work with the module here. How they work with the module, right? So think about for this one, right? I need to get a name and balance from employee, and every time I just print it out address here. Every time I print it out address here, ABC Manufacturing, 47 Park Lane, and Omro, Wisconsin, and so on. Right? And later on, I want to print out the name and the balance here. So you see, this one is in the flowchart, and this one in the pseudocode. And the process is quite simple, right? I need two variables here, name and balance. Name and balance, right? So I get it from user. Right? I print out address of him. Actually, every employee they have the same address here, because in this manufacturer I have multiple employees. Right? For each employee, I need to get the name and balance of him. I print it out address for them, and I print it out his name and the balance. So we see the process here. Every one of them, right? Every one of them, they have the same address here, because they work on the same manufacturer, right? They work in the same manufacturer here. Every one of them, they have the same address here. So you can see if I run this one with the Python here, it's very simple program, and later on I explain it later. My program. You don't have to follow me with the Python here, but anyway, I try to explain the concept here. So this one here, right? When I execute program, I need to get the name, I need to get the balance, and I just print it out, the name and balance here, right? So I print it out address, they are address here. Every employee, they have the same address, right? And I print it out name and balance here. So when I run my program here, let me close. Open video. Think about this one here, right? I put a David here, and I put 1,000 here. So the program is very simple, right? I just get the two variable. I start the name David and the balance 1,000 here. I print it out his address here, and later on I print it out customer name David and the total 1,000 here. This is very simple program, and I don't do anything with the modularization yet. I have not done. I don't do anything with the modularization, right? But the thing here, you can look on this one here. Think about if I do it for 1,000 employees here, right? You see, if I do it for 1,000 employees here, so everyone I have the same process, right? Because everyone they have the same address of the manufacturer here, right? So you see, if I do it for 1,000 times, it consumes a lot of time for me. I do it again and again and again, right? So instead of using that, I can work with modularization here. I can group them together for this one here. I can group them together and I define them one module for this one. Right? So I can define this one module as address here. Right? So every time I call the address module here, it executes exactly the same. I print it out the manufacturer, it printed out address here. Right? So now you can see in my program here. You can see in my program if I work with the single code here. Okay. So when you work with a modular program, right? Every statement you have to take out of main program. You put it into the module. You take it out of main program and put it into module, and that's the process of the encapsulation here. And also, module they are reusable. You can define one time, but you can use it again and again and again for multiple times, right? And also here, think about this one here. Now, if you look into my original program here, right? If you look into my original program here, this one. Yeah. If you look into my original program, I can group them together here. I can group them this one here. Because I know that I have 100,000 employees, and all of them they have the same address, right? So I can group them together. I can group them together, and I define this one with the display address here. That is the module. So remember that when I put them into the one module, I have to take it out from the main program and I put them into this module, right? So if you see in my program here, if you see in my program, right? So if you see in my program here, you can see what happened here. You can see what happened here, right? So basically, I group all of them here. I group all of them here, right? I take it out from my original program. I put it into the new module here. Right? So whenever you define the module here, you have to take it out from the original program and you put it in, you encapsulate it into the module here. Right? So what happened with my program? Execute everything in the order here, in the sequence order, right? Declaration here, get input here. Now what happened? That is the process I call for the module. Right? So when you call the module, for sure you have to define it somewhere. You have to define it somewhere, right? So what is it? When you call for this one here, actually it's the process here. You jump it to the module I defined here. I take it out from the main program, I put it into the module here, right? So what is it? When you call it, it jump to the module here, it execute for this one, it execute for this one, execute for this one, and what is it? When you have return. Remember when you have return here, you come back to the program that call you, and you move to the next statement. And later on, I just print it out customer name and the total. So basically this one here, when you execute this program with the original one, they work exactly the same. They work exactly the same. The output is the same. Sorry, the output is the same, right? The process is the same. You just get the name and the balance and print it out the address and print it out name and the balance here. But this one, you use a modular structure here. And you look in the program, you know that this process here is the process that you print it out address of every employee here. Now, if you look on this program, you don't see any benefits because it's a very simple program, right? This is a very simple program here, but if you work with the complicated program here, you can see a lot of benefits when you work with modular structure. It's very easy for you to manage your code and also you can work in parallel here. You can assign each team with one module, and you can work together parallel to each other here, and so on. You can reuse this, and you can divide one time and use for multiple times. But I just want you to look into the process here, right? So you see the process when you do the modular structure here, that is in the flowchart. You see, when you flowchart here, you call for this one, you accept it to that, take it out, execute, and go to return here. And this is the process when you work with pseudocode here. This is the process when you work with pseudocode here. So you see the process here. What is it? You have the declaration here. You got the input here. Now we call for the module, right? That's the process you call for the module here. So remember, the execute exactly the same. When you call for the module, it starts from here, right? It starts from here. It jumps into the module. It executes everything inside the module from the first statement to the last statement, and you go to the return. You move to the next statement here in the module, in the program that code you here. Make sense? Okay. Now you can observe it when I work with the Python here. It's a Python here. You can observe it when I work with the Python here. So I open file. Yes. So you don't have to work with the Python right now, but I explain the concept here. Also, right? I explain the concept here. So if you look in my Python here, the program actually every program in the Python, the first step is execute from main program. Right? So when the main program here, it do everything. That I get the name, I get the balance here. Now you see, that's the process I call for the module. Right? It's a call to module here. So I start from here. The program jump it to this one, print it out here, print it out here, print it out here, and when it's done, he move to the next statement here. I print out name and print out the value. So the process is the same, but now I work with the modular structure. Right? I group some of the code here. I bring it into this function here. Display address is for who. Make sense? And now, so we see what happened with my program here. Actually, the output is the same. Right? The output here. When you see the output here is the same. Yeah, so see, I do the same here, values here. Right? I have the 1000 here. So when you compare them together, right? When you compare them together here, this one and this one, they have the same output here. The only difference is that this one I work with modular structure. I define the function. And for this one, you don't see any benefit. Right? You don't see anything. It's the same. But what happened here? You see what happened? If I have 100 or 1000 employees, you can see what happened. I don't have to write every code here again. I can divide one time only, but I can do it again and again for multiple ones. I see. That's why I come up with another program. I come up with another program here. I open the file and this one here. Module number 3. Yes. Now this one. This program a little bit different. This program a little bit different here. The only difference, the difference here is that this one, I don't work with one employee only. I work in multiple employees. Huh? I have many employees in my company, and for each of them I get the name and I get the balance. I print it out each of them. But the thing is that all of them they have the same address. They have the same address here. That's why I identify one time, but I can work with multiple employees. We said now we see what happened with my program here. You can see what happened with my program. So we see in my program here, I execute it here. See what happened. All right. So this one I have A, I have 1000. All right. I do it. Now I have B, I have 2000. I do it. Now I have a C, I have 3000. I do it here. So we say the process here, I define for one time only, but I can apply for multiple employees. That's one of the benefits when I work with modularization. Right? But again, I mentioned that all of the programs here, they are very simple programs. You don't see much of benefits when you work with modularization structure here. But for sure, it's really helpful if you have a very complicated program here. You can break it down into multiple structures, multiple blocks. Okay. So think about I do the some simulation with this one here. I think about I come back to this program. I come back to this program here. This one. Okay. Think about this program. I have my program here. Now it's very simple program, but again, I want to break it down into the with the modular structure here. So it depends on you. It depends on you. It depends on you. You want to define one module or two module or three module. It's up to you. Because later on, if you have the completed program here, you have to make decision how many module you want to break it down. But this one, it's very simple, right? So think about for this one here, I want to break it down into two modules, right? I want to break it down into modules. This one, I break it down into the getting input, right? And this one, I break it down into the processing and output. I break it down into two modules here. So how we do it? Remember, if you want to break it down in the module, you have the text statement here in the main program. You put it encapsulate it into the module. Right? Think about this one here. I break it down with my program here. Right? So I copy everything the same. I copy everything the same here, but now I do with another program. This one I work with modular structure here. Modular structure here. Yeah, so now for this one, right? I think about this one. For this one here, I copy everything, I put it into the another module. Right? Getting input here. Remember, the module name is the same, it's quite the same with variable name, but it's followed by the parenthesis. Right? So what is it? I just painted everything here. And remember, I need to have the return. I need to have return to tell that is the end of the module, and I have to come back to the program that code in here. Right? So I define here. So that's why in my main program here, I just need to code here. I need to put it code here. Right? And again, I can group everything here. Right? I can group everything here into the processing and output. I can delete this one. Sorry. This one. Right? Delete this one and then put it into the another module here. Can put it into another module here. And this one, I have the processing output. Okay. I put it there. And of course, I defined already, right? So I can pour it in my main program. Yeah, that's the way I work in modular structure in the C code here. So what is it? How we execute program? Again, program execute in the main program here, right? So what is it? I execute from start here, right? Execute with declaration here. Now what is it? I call for the module name, getting input. So remember when in the program here, when you call for the module, you start from here. You start from here, right? And start from here, and you have to jump into the module you define here. That is the name of the module, right? So now again, you execute everything. You got it input, and return. What's the return? You have to come back to the program that call you, and you move to the next statement here. And again, in next statement, you call for the processing here. Right? You call for processing again. Start from here, and you move to the processing. You execute everything inside the processing, and when you return, you go to the end of the main program. Right? So if you look in the main program, it's very easy for you to figure out that this one you have two modules, and one of them is the getting input. The second one is the processing and output. Right? And again, remember that this one is very simple program. You don't see much benefit here, but the concept is very important. You know how you call the module, how you define the module. Because it's really helpful later on when you work with the complicated program. Make sense? Okay. So in the case when we work with modular structure, here, you have some benefit when you work with modular structure here, and I list it down here. The first one, easier to read. Easier to read because if you look into my program here, if you look into my main program here, I know for sure that you have the two modules for this program here, right? I understand the concept here. This one, I need to get input, and already got the input, I do the processing and output here. Right? The first thing, help you easier to read here. Easier to read. The second one, easier to design, code, and type program one module at a time. Because if you break it down into the smaller module, you can give it to the specific team. And each of them, they work with specific work already. And it's very easy for them to test in his code already. Right? The second one here, easy to design, code, and type program one module at a time. Different program module can be designed or coded by different programmers. You can break it down into multiple teams and they work parallel together, right? You don't have to wait to each other here. A single module may be used in more than one place in the program. That's what I show you, right? I define it for one time, but I can use it for multiple times. Right? If you look into my Python here, this one here, right? So see what happened. I define it for one time only, but I can use it for multiple employees. Right? Okay. What is the next one? Right? In module that perform common programming tasks can be used in more than one program. So later on, when you learn about module in the Python, you can import it from another module. You define it in another program, and you can reuse it into the another program also. Not only in your program. Right? It's really helpful. So think about, you get the code, you got the open source from somewhere, you can embed it in your work here. So basically, right, that's the process when you work with the module and when you define the module. So when you define the module, also you have the process. You work with the variable and the constant here, right, with the module. And some of them, it depends on the scope of module. Some of them, they are global. The global, that means you can use it in any module. And the second one, local, that means it only works in the specific module. I think about this one. Think about, I have local here. In the Python. Think about this one. Yes. So now in my program, right? In my program, I call for the main here, and I call I call for the display here, right? I display here, and I get the number. I print it out the number. I want to add it by 10. I want to print it out exactly here. So we see what happened with my program. What happened with my program? Number 10. Right? This one, I got the syntax error because act here in this program here, right? It doesn't understand where the act come from. Because act here actually is the act here, right? You see, when you call for the display here, when you call for the display, this one, right? Here. When you call the display here, you call for the act here and act here. Remember, act here is a local variable defined in the function display over there. But later on, when I call it from here, it doesn't understand where I come from because it is local variable. So in that case, you have to work with global variable. Okay? Now, yeah, that's the case. You work with you define the declare variable and constant, which is the module here. So basically, it's the same process here, right? You see, all of the manufacturer here, Park Lane here, and Umbro, Wisconsin here, it belongs to this. It belongs to this module array, right? So it should be better you define in this module array, not in the global variable here. That's when you work with this program here, right? So we see for this one, you have name and balance, they are global variable. But for the for all the thing here, line number 1, line number 2, and line number 3 here, they are local variable, and they only defined in this module only, contained in this module only. I want to skip this one. I come back to this concept later. Now, about hierarchy. So you learn about the flow chart already. Right? The flow chart is very helpful for you to work with the same with the planning logic about the civil code here. The other thing you learn in this class is a hierarchy chart here. So what is the hierarchy chart? Right, hierarchy chart is shows the relationship between the module. Because when you break program into the multiple module here, when you call them together, right, you have to show relationship between them. So the hierarchy chart is shows the overall picture of how module they are related to one another here, and tell you which module exists within a program and which module call other, because they show the relationship here, right? And specific module may be called for several locations within the program. Right? Some of the tool you can work here, you can develop overall relationship program module before you write them. So think about this program. Again, come back to this program here, right? So come back to my program here. Where? This one. Right? So this one, you know that for this program, I have one main program, and I have the two modules here. I call the two modules here from main program, right? So I want to show the relationship between of my module here. So in that case, I can work with a draw arrow here. Create a new one. Remember one thing here. Remember one thing when you work with when you work with a hierarchy chart, you only show the relationship between the module. You do not have to put every statement inside the module. Remember that, right? So now in my program, you see in my program here, I have the main program, right? This is main program, and inside my main program, I call for the two modules, getting input and processing and output here, right? So I know that from in my program here, I have one program, right? I have the one program here. This is yeah, I can work with this one, right? I have this one is the main program, right? Main here. And you know, for in the main, I call for the two submodule here. One of them, right? One of them is a getting input. Right? One of them is getting input here. Yeah. Copy this one, I paste it here. And the other one, it is the other one. The one I have processing and output here, right? Here, processing and output here. So now I just connect them together, right? So I know that from my main program here, I call for two of them, right? I call for two of them. The first one is yes, I'm not drawing it, but anyway. So this program is very simple, right? This program and this is hierarchy chart. So remember, hierarchy chart is show the relationship between the module, right? So if you look into my program here, I know that in my program, right? In my program here, I have main program, right? And in main program, I call for the two modules here, getting input and processing and output. That's all. But you can think about in the complicated program here. Think about in the complicated program. Sometimes you can break it down into multiple levels of the module here. Now this one, I think about this one, right? So you can think about that is an example of the hierarchy chart here. So see, it break it down, right? It break it down the housekeeping, detail loop, and end of job here, and of course later on here, right? Later on, right? sorry. You can call into the another module. And this one also, you can break it down into the module here. And again, you can break it down into the another module also. Right? My mistake here, actually. This one, you only need the rectangle. When you work with the flowchart, you need to use a bar here. Right? So basically, I make mistake with this one. You don't need to use this one. Actually, for this one, you certainly need to use a rectangle. Yeah, but when it's flowchart, you need to use it.
So why do you only use a regular rectangle instead of the?
Let me explain.
Okay.
Okay. So remember, this is hierarchy. Hierarchy is some relationship between the module, and you only stop at the module name. You don't have to put what you do with the getting input here. You don't have to put what you do with the processing your output here. You don't have to, because they are statements inside the module, right? So if you work with the hierarchy chart here, you only stop at the module level, and you show the relationship between the module here. So if you look on this one, you know that you have one main program, and in the main program here, you call for the getting input and you call for the processing output here. This is not flowchart. Remember, flowchart you have to work in detail what you have inside each of the module here. Right? So that is, you think about this is a main frame. You know that the overview of your program and how they are related together. But if you want to look into more detail about program, about each module, you have to look into the flowchart here or pseudocode here. Right? Okay. So basically that is hierarchy chart for this one here. And if you this is a hierarchy chart for this one. And if you want to work with the flowchart here, again, you have to do with the other one, right? You have to work with the flowchart here. You have to start here. You have to start for this one, and again you have declaration. You have declaration here. You have the declaration. So I just copy it here. Let me do the program. This one, wait it here in my flowchart here. In this one. Now, in my program, right? In my program here, I call for the getting input, right? That's why I use this one here, right? I use for the code getting input here. I paste it here. Right? I call for another one for the processing and output here. Put it here. Put it here. And after that, I have stopped. I have stopped my program. Okay, of course I need to connect them together. I need to delete the arrow here. I need to leave arrow. But I have not done yet. This is only main program, right? That is main program, and in the main program here, I have action to call for the getting input here. That's why I have to define. Right? So again, if I want to define for the getting input here, I have to use this one here, right? I have to use for how we do this one. The same with this one, right? So see, if you want to break it down, but not this one, right? That one. I'm not yes, this one here, right? You have to define it later here. Huh? Okay, this one the same with this one also. If I want to do it, if I call for getting input here again, I have to define it. And the name of the module here is the getting input, right? The name of the module here is the getting input. Again, I have to put every statement. What I do is getting input here, right? That's why I have in my program here. What is it? The program here, right? I do this one, right? So I need to get input for this one. So I use a parallel program here. I put this one. Of course, you have to modify it to look it better for. You have to change the format and so on here. And again, I do the other concept here, right? I got it here, and there's a number 2, another. Start into the number 2. Right? Now remember this one, you have to return it, right? Not stop. Stop, that means you only use it in the main program only, right? You have to return it. So that's the process, right? So we see in my program, right? This is the main program. You have start and stop is the main program. That is a module, and of course you need to connect them together, right? That is a module. Huh? That's a module. So we see when we execute main program, I call for the getting input here. What is it? It jump to this one. It executes this one. Executes this one. You go to return. When return, you have to go to the module that call you, and you move to the next statement here. And again, I call for processing and output here. I have to define it later. That's all. So I have to define it here, right? So in the case here, I define here. I define it. I need to connect them together, right? But I don't want to use here. So anyway, I have to do another one here, right? This one. Again, the name here is the processing and output. Processing and output. And what I do with the processing and output, I just copy everything here, right? And so you copy everything with the processing here. Right? So I make it simple by using the one block only. If everything is the processing, I use a rectangle here. So I put everything in the processing, I use a rectangle here. Should be better you break it down into the multiple block here, but I do it a way I just want to simulate. Right? So I do the processing and I do the output also. Right? I have output also. Processing here and the output. Remember that output I have to use a parallelogram here, right? And I put it here. First, you have to modify it here. You have to make it better with the output here. Okay, and you should change. You should do the format to look it better the way I do it. And of course, last thing, I need to return. Right? I need to return. Okay? And I need to connect them together. Right? I need to connect them together step by step. I need to connect them together. So that's the way I work with the flowchart here, right? So see, I work this program with both of the first one here. If you look first step, right? That is a highway chart to give you the overview how the program work, how they are related to each other, how the module related to each other, right? And you know, because it's very simple program. You break it down into the module getting input and processing and output here. And again, so when I define here, I have to declare, right? What is the getting input? That is my main program. That's the flow chart. Remember, this is highway chart, but everything here, right? Everything here, they are flow chart. This is main program. This is getting input, and this is processing and output. Make sense? Okay. So you guys take a short break for 5 minutes and come back.